Welcome to another podcast. This episode we're going to be taking a look at the DEplot command. We've used this command at several points throughout the semester. And we will continue to use it throughout the semester. I just want to briefly go into the command structure and a couple of additional options that you can use. So the basic command structure here is going to require that we load the DEtools package. Remember, to load packages, you need to use the with command. So we're going to say with DEtools. If I don't put the colon at the end of it and just hit enter, you can see that it loads many different packages, one of which is DEplot that we're going to have access to. But generally, we don't want to see that information in our Maple files, so I'm going to suppress it by putting a colon at the end. Now, the basic structure of DEplot is going to be just like dsolve. We're going to need an ordinary differential equation to do it, so I'm going to define the variable ODE, or name the differential equation ODE, and I'll just do a simple sort of linear equation here. So here is this is just a first order linear differential equation. So I will store it to ODE, and then what I can do from there is invoke the DEplot command. And normally if you're doing dsolve, you would just do ODE followed by the dependent variable. And that would solve the general solution for your differential equation. But I want to solve the equation, generate a slope field, and then show solutions. And that's more than dsolve by itself can handle, which is why we needed to load the package. So we've got DEplot, and it's going to start off just like dsolve. You load the ODE, you tell it that y of t is the dependent variable. But then because it's going to plot, you need to give it a window. And so the window here would be the t variable and the y variable and what their limits are. Now you could go in and adjust this and change it, but just that is the minimal command needed to produce a slope field. And so we've talked about slope fields in class, but basically they're a representation of the direction of solutions to the differential equation at any point in the plane. In particular, what I could do with this is several things. I could go in and modify the arrows. So the normal maple arrow is, for a slope field, is kind of this harpoon shape. I can go in and say arrows equal medium, and it'll change it to more of a traditional two-sided arrow. I could go in and use the optional argument color to change the slope field to a blue color, which I tend to like better. The other option that is a really neat option, I'll just copy and paste the command here, is to add something called the direction grid. So dir grid. If you will look at the slope field as shown, you'll notice that the number of arrows plotted along any horizontal stretch is 20. So this is a 20 by 20 grid of little mini tangent slopes that are calculated. In other words, there's 400 arrows on this picture. Sometimes that might be too much information, sometimes it might not be enough. So here, if I did 10 and 10, then that would be a 10 by 10 grid of arrows. You can see that that's quite a bit less sparse. Or if I needed denser information, maybe because I couldn't really tell what was happening, I could up it. I wouldn't recommend upping it too much, but maybe I can try a 30 by 30. And you can see that that's a much finer grid. It tells me exactly what's going on with the equation. Any more than that and you lose a sense of arrows, but sometimes that's useful. These are the basic commands and options that you'll need for solving and plotting slope fields in this class. Now, we're often used to, when it comes to ODEs, and we do dsolve, we would do something like this and produce our general solution. However, oftentimes we want to solve for this constant, and the way that dsolve handles that is by grouping the ODE together with the initial condition, thereby solving for the constant c. So you can see that the c1 constant was solved for, and it looks like it's equal to this. So how do we replicate that in DEplot? Well, the basic way of doing that is taking the DEplot command. You can see the various grids that we've established here, but inserting right after you define the variables. So after you define the plotting variables t and y, insert square braces. This is the list environment for Maple. So we're going to create a list of conditions. So I'm going to graph not only the slope field, but I'm asking Maple to also graph this solution, which is the solution to the initial condition y of 0 equal 1. And so applying this particular command is going to accomplish that. So you can see here, if you look at the point 0, 1, the graph passes through that point. So what I can do is change the color associated with that. I can say, okay, I want the line color to be red. So depending on what your preference is for colors and what you think shows up best, you could have multiple colors going with multiple solutions. Now let's talk about how to do multiple solutions, and it really is as simple as listing more and more initial conditions. So maybe another initial condition is y of 1 equal 1, y of negative 2 equal 3, so that I have 3 total conditions. If I hit enter and return, you can see it graphed all 3 of those. What if I wanted them to be different colors? Well, if I wanted them to be different colors, then I can, under line color, suggest colors for each of them, and it would change the colors used. Now, it's not a one-to-one comparison, so be careful about this. You can see that just because red is listed first, Maple does not take the first condition and apply it to red. I don't know exactly how it picks the order that it does, but you can see red here is 0, 1. Brown is not 1, 1. Brown is corresponding to negative 2, 3, I believe. Yeah. So brown is corresponding to... No, I guess brown is corresponding to 1, 1. Yeah, that's right. So brown is corresponding to 1, 1, and y of negative 2 equal to 3 is the green. So in fact, it is corresponding. Once upon a time, Maple did not make those correspond, and it was very confusing, but it looks like they fixed that now. So the first initial condition here will correspond to the first color here. And so that's a good way of kind of showing what you're doing in your graphs. And we've talked about in the plotting commands how you can use things like labels and titles to make your graphs look more effective. That's sort of a basic introduction to the DEplot command. There's really very little else I can add to this that'll help you right away in this course. Maybe later in the semester when we get to some more specific things, we might do that. I will remind you, however, and I'll keep reminding you of this throughout the semester, if you run into problems with commands, always go to Maple Help, type in the command that you're working on. Here, DEplot is my command. And you can see when I look at DEplot, it's under the DEtools package, so it's loaded by that package. It tells you all the different ways of initializing it, and it's got several different options that it explains and shows sort of worked out examples for the DEplot. And so I encourage most students to go through and take a look at those throughout the semester. Aside from that, this is a command we will use often in the semester, and so you need to become very comfortable with it. All right, thank you for watching.